1F, classifying and ordering numbers. So we're going to start out with square roots. Square roots is kind of like, you know, part of the whole multiplication division thing. It's kind of like in a specific order in the sense that, like the square root of a number, you're trying to find what times what gives me that number, and my answer is that thing. So what I kind of want to do is start out the class now. I'm going to zoom in. All right, so you guys need to write on like the side or something like that. I'm just creating like a white space for me to write. So you just write on the side somewhere. And here we go. So let's start out by writing our numbers 1, 2, 3, 4, 5, 6, 7, and then you guys keep continuing down. 8, 9, 10, 11, 12, 13, 14, and I'll go to 15. I can keep going, but I'm not really going to do it because you'll get the point. Now, this column here, let me write it a different color for you. This column we're going to call perfect squares. All right. So what I do to get that column is I do 1 times 1, which is 1. 2 times 2, which is 4. 3 times 3, which is 9. Anybody give me the next one?
16.
Okay. Somebody different? Like what's 5 times 5?
25.
25. 6 times 6?
36.
7 times 7?
49.
8 times 8?
64.
9 times 9?
81.
10 times 10?
100.
All right, so 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. And 15 times 15 is 225. So these red numbers on my board are perfect squares. Okay, they're perfect squares. That means the green column is the square root. Okay, so do you guys see how they're like related and how I get them? Now, knowing this, let's start the lesson and talk about all of this fun stuff. So all of this is kind of like mumbo jumbo and jargon and stuff like that. Okay, so all positive real numbers have 2 square roots. Okay, meaning, let's take 9 for example. 9 is 3 times 3. It could also be -3 times -3. So there's always 2 answers to a square root problem. Okay? The little check box or the little house looking thing is called the radical symbol. Okay? And what's inside it is called the radicand. Again, mumbo jumbo. 0 has only 1 square root, so the square root of 0 is 0. Negative real numbers do not have a real square root for the answer. So if I ask you to take the square root of a negative number, you're going to say it's undefined or not real. Now, when I'm asking you to complete square root problems, I will tell you if I want the positive answer, negative answer, or both. So for example, in number 1 down here says I want the negative square root. So I look back at my list and I say, the square root of 9, where was that in that red column? And then I trace it over to the green column and I see that the square root of 9 was 3. Now the negative outside right here tells me that I want the negative version of that. So my answer is -3. For 25, notice there is no sign outside, meaning I want the positive version. So I find 25 on my green column, or my red column, and I trace it over to the green column, and I see that my answer is 5. Now you can also do these on your calculator, okay? And you can just type in the square root of your number. Okay, and if you need help finding that, I'll show you where it is a little later so that we can keep the lesson flowing. But in short, on the graphing calculator, you hit the blue button and the x squared button. And that'll give you the square root. And then you just type in the number you want. So the square root of 64 here would be 8. And the square root of 81 is 9. And notice the negative sign out front. So my answer they want is -9. Any questions on that? Now for these, I do need my graphing calculator. So I'm going to go ahead and load that up. And now I'll show you where that square root symbol is. So the problems they want me to do are the square root of 32. Okay. So let's see, is this going to load? Yep. So I go back to my home screen because sometimes it's on whatever screen. So now I hit the blue button, this x squared button. I'm going to type in 32. And notice my answer says 5.65. And the instructions say round it to the nearest integer. So 5.6 rounds up to 6. So that's the answer to number 1. For number 2, I type in the square root of 103. And that would round down to 10, because 10.1 rounds down to 10. Negative square root of 48. I just type it in just like that. And that says -6.9, so that would round to -7. Negative square root of 350. That, -18.7, would round to -19. Are you guys okay with how to type that in on the calculator? So again, my answers were 6, or approximately 6, approximately 10. This was approximately -7, and this was approximately -19. All right, let's turn the page. So, perfect squares are numbers that have an integer for an answer when you take the square root. And that's a pretty formal definition. So perfect squares, those were the red numbers. Okay, so they were 1, 4, 9, 25, 36, 49, 64, 81, 100, 121, 144, ... Now, any number in between them, so say like 7 is not a perfect square. 14, not a perfect square. 32, not a perfect square, because it's in between two perfect squares. Rational numbers. So a rational number is any number that can be written as a fraction. So these numbers are like 0, -2, 1, 3/4, 0.6, 5, and I don't know, let's say -12. So all of these numbers, whole, negative, decimals, and fractions, are considered rational numbers. Now, not all decimals will be considered a rational number, but anything that like repeats or can be written as a fraction, like 0.6 could be written as 6/10, is a rational number. And to make something a fraction, okay, well, we could just be like, oh, 5 is 10/2. Or 1 is 3/3. Or -2 is negative 4/2. Now, irrational numbers are any number that can't be written as a fraction. So an example of this would be like pi, the square root of 7, negative square root of 2, e. All of these are irrational numbers because they can't be written as a fraction. Pi is the most famous, and any square root other than the square root of a perfect square is an irrational number. So as long as it's not a number that we wrote in blue up there, okay, or like when I type it in my calculator, I get a whole number, that's going to be considered irrational. Now, real numbers at this point are any number you can think of. So it's any number but the square root of a negative. So as long as we're not taking the square root of a negative number, it's real. So this is any number you could think of in the world. These are numbers that we can actually attain. Like pi is the ratio of the circumference to the diameter. It's something we deal with in the real world. Like I could actually like, you know, get that answer and physically like kind of put my hands on pi. Okay, square roots of a number. We deal with that all the time with measurements. The Egyptians dealt with it with the pyramids and all the triangles they used. But the square root of a negative number, it's not something you're going to come into like an encounter with in like carpentry or building or in baking when you're dealing with fractions. Like all of that stuff is like real numbers. All right. So if it's not real, it's considered imaginary, and we don't deal with that here. So this is kind of a little diagram, like whole numbers is a small group. These are like your counting numbers, like 0, 5, 16. So these are all my counting numbers, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are whole numbers. Integers are all my whole numbers and their opposites. And rational numbers are kind of like when you divide two integers, okay? That's a rational number. And then irrational are my square roots, as you can see. They're decimals that go on forever and don't repeat. All right, over here, I have a table and I'm being asked to determine whether it's a real number, rational, irrational, integer, or whole number. So I need everybody to do is type in these three things into their calculator real quick. Who can tell me what the square root of 144 is?
12.
Who can tell me what negative square root of 49 is?
-7.
Thank you. And what is the square root of 32?
6.
That was approximately from the first page, but what was it exactly? It was like 5 point something, right?
Yeah.
So what was that? 5.
It was 5.656854249.
And it kept going on, right?
Yeah.
It kept going on and on and on. So here, a real number. All of these are real numbers because they're not the square root of a negative number. Yes, my answer number, or like the second one, the square root of 49, the negative there, that is negative, but I'm not taking the square root of negative 49. So these are all real numbers. Are they rational numbers? Meaning, can I write them as a fraction? Well, 12 you can write as a fraction. -7 you can write as a fraction. But the square root of 32 you cannot write as a fraction. So I'm going to leave that box blank. Meaning, since it's not rational, the square root of 32 is irrational. And I leave the top two squares blank because something can't be rational and irrational at the same time. Now, 12 is an integer, right? Because it's a positive number. It's a positive whole number. -7 is an integer. But 5.65 is not because there is a decimal there. Now, 12 is a whole number, and -7 is not because it's not positive. Tell which or whether each of the following numbers is real, a rational number, an irrational number, an integer, or a whole number. So this is how we're going to do it. Square root of 49, 0, -6/4, -2, and the square root of 17. I think you guys can see where I'm going with this. Real, rational, irrational, integer, and whole. So I kind of made a table just like above. So the square root of 49 is 7. I'm sorry if I'm going a little fast, but I want to get done the last problem before the end. 0, 0, negative 6.4, well, we can leave it like that, or we can also deal with it as negative 1.5. Negative 2 is that, and 17 is 4 point something. I don't know what that something is, but I know it doesn't repeat. So let's look at these. Well, these are all real numbers because they're not the square root of a negative number. Rational. Well, 7's rational, 0's rational. Well, that's a fraction, so that's rational. And negative 2 is rational. But the square root of 17 is not rational, meaning it is irrational. Now, an integer, 7's an integer, 0's an integer, negative 6/4 is not an integer, it's a fraction, so I can't check off that box. And negative 2 is an integer. The square root of 17 is not because it's a decimal. Whole numbers. Well, 7's a whole number and 0's a whole number. And last but not least, we have these down here. Square root of 8, 7, negative 8/3, 0.6, and negative square root of 2. Real, rational, irrational, integer, and whole. So the square root of 8 is approximately like 3.8 or something like that. Don't have to do anything with 7. Negative 8/3, I'm okay with that. 0.6, I'm okay with that because it's a decimal. And the square root, or negative square root of 2 is like negative 1 point something. So they're all real because I'm not taking the square root of a negative number. Rational, well, that's going to be 7, negative 8/3, and 0.6. The square roots are irrational because they're decimals that go on forever. 7's the only integer because it can't be a decimal or a fraction. And 7 is the only whole number.